Hello, this is part two of Riemann sums, and in this video we are just going to do some actual problems involving Riemann sum. So example one says, find the left and right Riemann sum and trapezoidal approximation for the limit as n approaches infinity of f of x d of x from the intervals 0 to 7 of f of x d of x. And then they give us a table. So these are your x's, and then your y values are like they don't actually give you. It's just your y values f of 0, f of 1, f of 3, f of 7. They're not actual values. They're just uh, it's just f of 0, right? F of 1, f of 3, f of 7. So we have to do the left and right sum, and trapezoidal and the trapezoidal method. So there's three methods we have to do. So let's start with the left method. So the first step is I am going to draw kind of like an image, right? So our intervals is from 0 to 7. Oops. 0, there's 1, there's 3, there's 7. Okay. Now let's make a box. And okay, so what we have to do, so what is the distance? So what is an area? So we have, what is the area of a rectangle? So, because this is eventually a rectangle, so the area of a rectangle is base times height, right? Here you have a rectangle, your height, your base. It's also the same thing as your base could be also be expressed as your delta x, and your height could also be expressed as basically the height or f of x. Okay, so if you look from the distance from 0 to 1, that's a total distance of 1, or that is that's your base, also your delta x. And if you go from 1 to 3, your width is, or your base is 2. And then from 3 to 7, your delta x is 4. Okay. Now we have to go from the left. So this is the left side. Here's the left. Oops. Here's the left. Here's the left. Whoops. Maybe I should try another color. Okay. So we care about this side, and then this side. Okay, so let's look at this area right here. So our base is 1, and then our height is f of 0, right? Because this is your height right here. And you just look at your chart. What is the y value when the x value is 0? It just says f of 0. It's not an actual value, right? And then, oops. Now we have to do this side, this rectangle. So our delta x is 2. And what is my y? So we're focusing on this side right here, this height right here. So that is f of 1. plus this height here from 3 to 7, it's like 4, right? The change it from 3 to 7, your base is 4. And then we're focusing on this height, so it's going to be F3. Okay, so when you put it all together, you're just going to get this. It's not, unfortunately, we don't know what the Y value of F of 0, F of 1, and F of 3, right? So we're just going to leave it like that. Okay, so that is the left method. Now let's do the right. So if you kind of draw your image, same exact idea. It's just that now we're focusing on the right. Okay, from zero, so we're going to find the area of this box, and then the delta x is also 1. Over here from 1 to 3, our delta x is also 2. And then from 3 to 4, the delta x is 4. Okay, and then this time we only care about the right side, so let me use this. We only care about this side, this height, because we're focusing on the right. And then don't forget this side. Okay, so let's find the area of all of these three boxes. So the area of the first box, the delta x is 1, and the height is now not f of 0, but f of 1. Plus, you look at this box right here, the change of x is 2, and then the height is not f of 1, but f of 3. Over here from 3 to 7, it's like 4, and the height is f of 7. Okay, so unfortunately, we don't know what the actual height of f1, f3, and f7, so we're just going to leave it like this. Okay, so we still have to do the trapezoid method. So let me put it right here because I'm running out of space. So how do we do the trapezoid method? So let me draw the image again. Okay, so here we have three trapezoids, and these are trapezoids. If you kind of rotate this trapezoid, it would look something like this, right? This is your base 1, this is your height, and then this is your base 2. So if you turn this trapezoid on its side, uh, you're going to get, it's going to look something like this. Right here's your f of 1, f of 2, and then your height is your delta x. So what is the area of a trapezoid? Well, the area of a trapezoid is 1/2 delta x of f1 plus f2. Okay, so let's go find the area of these three trapezoids. So when you take the area of the trapezoid, you're going to need, like for example, on this trapezoid, you're gonna need to find the height for f of 0 and f of 1 because that's your base 1, base 2, right? So it's going to be, so if you look at the first one, it's going to be 1/2, and the height is 1. Or, so your delta x, see, if I use this formula, our delta x from 0 to 1 is 1 times these two heights. So you got to do f of 0 plus f of 1. Okay. Now let's do the other trapezoid. It's going to be plus 1/2, and then the delta x, what's the distance from 1 to 3? 2. And then you got to find B1, F1, and F3. Plus 1/2. The delta x from 3 to 7 is 4. And then it's going to be, you got to find the height of f of 3 and f of 7. And that's it. That is, unfortunately, we don't know the height of f of 0 and f of 1, or f of 1 and f of 3, and f3 and f of 7, so we're just going to leave it like this. Or you can simplify it. What's 1/2 times 2 becomes 1. What's 1/2 times 4? That becomes 2. Okay, so that's the answer for this one. Okay, let's move on to example 2. So find the left and right Riemann sum and trapezoid approximation. This time we're going from the intervals 1 to 4 of f of x d of x, and they give us exactly the same table. So just like the last one, let's do the left. Excuse me. So our boundaries is from 1 to 4. This is okay. So let's do the left. So here's our two boxes. So area of a rectangle is base times height, or delta x times the height. So from 1 to 2, the delta x, or the change of x, is 1. From 2 to 3, the delta x is 1. And then from 3 to 4, the delta x is also 1. Okay, so let's find the area of this box. And then this time we're going to the left, so we only care about this height. So my delta x is 1, and my height is f of 1. Plus, if you look at this box right here, my delta x is 3, 1, and then my height is this height right here, f of 2. Plus, if you look at this rectangle here, my delta x from 3 to 4 is 1, and then my height, we only care about f of 3. So what do they all have in common? They all have a height of 1. So if you want, because they all have a common height of 1, you can factor out that 1. So you can say 1 of f of 1 plus f of 2 plus f of 3. Okay, so this is your answer. And unfortunately, we don't know the actual height of f of 1, f of 2, f of 3, and 4. So we're just going to leave it like this. Okay, let's do the right side because they do ask for right. Okay, so here's 1, 2, 3, 4. Okay, so let's look at this box right here. Okay, so from 1 to 2, the delta x is 1. From 2 to 3, the delta x is also 1, right? 3 minus 2 is 1. And then from 3 to 4, the delta x is 1. Okay, so if we're going to do the right, okay, so let's look at the first box. What's the delta x? 1. What's the height? This time, if we're doing the right side, we're going to focus on this side right here. Let me use another color so you can see. So this height right here. And that is on f of 2. Plus, if you look at the second box, my delta x from 2 to 3 is 1. And then if you look at the height, it would be f of 3. Plus, if you look at the third box, from 3 to 4, the delta x is 1. And then the height is f4. Okay. So what do they all have in common? They have a 1. So it's going to be 1 times f of 2 plus f of 3 plus f of 4. And then the last method is trapezoidal. Yeah. 1, 2, 3, 4. And then we're going to make some trapezoids. First trapezoid. Okay, so what is the area of a trapezoid? It is delta x plus, what is it? So it's so the area of a trapezoid is 1/2 times the height times base 1 plus base 2. Okay, so it's going to be, so if you look at this first trapezoid, it's going to be 1/2, and then the distance from 1 to 2 is 1. And then we got to find times it by the base 1 plus base 2. So here's your base 1, so that's f of 1 plus, and then this other height is f of 2. Okay, and then plus, and let's do the other trapezoid. So it's going to be 1/2. And then my height from 2 to 3, or my delta x is 1, because 3 minus 2 is 1, times the base of b2 and b3. I mean, f3, I mean f2 plus f3. Okay, and then the next one is the other trapezoid. Uh, it's going to be 1/2. The distance from 3 to 4 is 1. And then f3 and f4. get that. So as you can see, 1/2 times 1, you can factor out a 1/2, right? They all have a 1/2. So if you want, you could factor out that 1/2, and then it's going to be f of 1 plus f of 2 bracket, no, no brackets, not yet. So f of 2, f of 1, f of 2, and then also another f of 2, right? And then f of 3. And then you also have this extra f of 3. And then f of 4. Okay. So if you look at questions 1 and 2, what do you see that's different and the same? If you go back to questions 1 and 2, what do you see that are different and the same? You see that the delta x are different, right? So so delta x are different. So here's just an important note. Delta x is unequal. Different, you can if delta x is unequal or different, you must calculate each rectangle trapezoid separately. So later on, you'll see an example where the delta x or the distance from 1 to 2 might not be the same. You have to just uh, calculate each rectangle trapezoid separately. So let me write this down. And delta x is unequal. And then if delta x are equal, then you can factor out to simplify. So if delta x are equal, like for example, they all had a 1/2, you could just factor it out and simplify. Okay, so let's move on to example 3. So let f of x equals x cubed minus 1 on the intervals from 0 to 8. Let the interval divide into 4 equal subintervals. Find the Riemann sum, left endpoints, right endpoints, midpoints, and trapezoids. Okay, so there's 4 methods we have to do. So let's kind of draw our image. Right. What is this? What does x cubed minus 1 look like? It looks like this. It's an odd degree graph. It has a y-intercept of -1. It's going to look like this. Okay, we got to find the area here. And then we also gotta find the area here. Okay, here's f of x. And we stop at 8. And then where do we start? We start at 0. Sorry, yeah. So from 0 to 8. So yeah, that makes sense. We need to find this area and this area. So let's first find our delta x. Yeah, so let's find our delta x. So delta x is going to be base minus a over h. So my base is 8 minus my a, my starting point is 0, and my height is 4. I mean, why? So it's basically stop minus start divided by number of rectangles. So stop minus start divided by number of rectangles. So it's going to be 8 minus 0 over 4, which is 2. So let's do A, the left side. So it's going to be delta x of f of x0 plus f of x1 plus f of x n minus 1. So now let's draw our triangles. So we're going from 0 to 8, right? Here's 8. Here's 0. Here's 2. Here's 4. Here's 6. Here's 2. Okay, so we got to find the left side, right, of these four area of these rectangles. Okay, so from 0 to 2, what is the distance? It is 2. From 2 to 4, the delta x is also 2. From 4 to 6, the delta x is also 2. And then from 6 to 8, the delta x is also 2. And if we're going to the left, that means we use another color. So we're going to focus on this side as this height, this side, and then this side, and then this side. Okay, so rectangle 1, 2, 3, 4. So the area of rectangle 1 is, so look at, they all have a delta x of 2. So what we could do is just factor out a 2. And let's just find the height. So you got to find the height of f of 0 plus f of 2 plus f of 4 plus f of 6. And this time, because they give us an equation, y equals or f of x equals x cubed minus 1, we can actually find the y value. So if you plug in 0, you get 0 cubed minus 1 is negative 1. Plug in f of 2, it's going to spit out 7. We do f of 4, it will spit out 63. And then if you do 6, it will spit out 215. Okay, so it's going to be 2, and then f of 0 is negative 1. F of 2 is 7. F of 4 is 63. F of 6 is 215. Okay, put it all together and you get 568. Okay, so we just did the left side. Now let's do the right. So let's do the right now. Okay, so F2 is right here. Okay, so F2, so here's F2. So we're doing the right, so on this, and then F4, F6, and then F8. So here's the right side, here's rectangle 1, 2, 3, 4. Let's find the area of that. So they all have a delta x of 2, right? Right, 0 to 2 is the distance is 2, from 2 to 4 distance 2, 4 to 6 distance 2, etc. So you could just factor out a 2. And then if we're doing the right side, we got to find f of 2 plus f of 4 plus f of 6 plus f of 8. Okay, and then because they give us an equation, f of x equals x cubed minus 1, we can actually find the values. So find f of 2. So if you plug in f of 2, you should spit out a 7. If you plug in f of 4, you get 63. And if you plug in f of 6, you get 215. And if you plug in f of 8, you get 511. Okay, so f of 2 is 7, f of 4 is 63, f of 6 is 215, f of 8 is 511. Okay, so when you put it all together, you should get 1592. Okay, so that was the right. Now let's somehow do the midpoint. So how do you do the midpoint? Here, I'll show you. So from 0, and then you'll end at 8. And we're going from 2. Okay, so they're equal increments of 2. So this would be 2, 4, 6, and 8. Okay, here's 2. Just to pretend these are equal. So with the midpoint, you get more rectangles because it should be more accurate. So what you have to do is find the average between 0 and 2. So it's just 0 plus 2 over 2, which is 1. It's 1 straight line like that. And then the distance from 2 to 4, I mean, halfway points between 2 and 4, it should be 3. And then halfway point between 4 and 6 should be 5. And then halfway point between 6 and 8 should be 7. Okay, so uh, let's see. So our delta x from 0 to 2 is still 2. The same thing with 2 to 4, it's 2. 4 to 6 is 2. 6 to 8 is 2. So our delta to x is 2, so you can just factor out that 2. And what you have to do is, so the midpoints, you're not doing the right or the left, you're doing the midpoint. So you got to find f of 1, f of 3, f of 5, and f of 7. So f of 1, 3, 5, and 7. And what do you get? So our function is f of x equals x cubed minus 1. So f of 1 is 1 cubed is 1, minus 1 is 0. F of 3 is 26. F of 5 is 124. And F of 7 is 342. Okay, so f of 1 is 0, f of 3 is 26, 5 is 124, 7 is 342. Put it all together, you get 984. Okay, the next one is trapezoid. Or D, we're going to do trapezoid. So here, let's draw the image. 0, 2, 4, 6, and was it 8? Goes 2. Okay, so we're going to find the area of these trapezoids. So at height 2, it shares two areas. That means it was counted twice. So the area of a trapezoid is 1/2 delta x. And then remember, we have to find the two heights here and here, and then here and here, here and here. So it's going to be, they both have a delta x of 2, right? From 0 to 2 is 2, from 2 to 4 is 2. So it's just going to be, yeah. So it's going to, we could factor out a 1/2 and a 2, right? Because they all have a 1/2 and a 2. And then let's just find our height. So let's find f of 0, right? And then f of 2. And then f of 4. And then f of 6. And then f of 8. And we can actually find the actual value because they tell us that the function is x cubed minus 1. So let's find f of 0, which is -1. F of 2 is 248 minus 1 is 7. F of 4 is 4 cubed minus 1 is 64 minus 1, which is 63. And f of 6 is 6 cubed minus 1 is 215. And then f of 8 is 8 cubed minus 1, which is 511. Okay, put it all together. So 1/2 times 1, that just becomes 1. F of 0 is -1. F of 2 is 7. F of 4 is 63. F of 6 is 215. And then F of 8 is 511. Okay, put it all together. Uh, you should get 1080. So if you're curious how accurate, if you're so curious about how accurate the trapezoid method, so later on you could actually find the exact value. So if you take the integral from 0 to 8 of x cubed minus 1 dx, if you do all the work, or if you put this in the calculator, you get an exact value of 1016. So if you compare a 1080 to 1016, that's pretty darn close, right? So it just proves that the midpoint and trapezoid is the most accurate. Okay, I think we can just stop here because the video is going to take too long. Like, I'll do the last three examples in another video. Okay, so I'm going to stop here.